So in this related rates problem, we read that square ABCD, 30 centimeters on a side, is drawn on the pavement. Okay, an ant is observed crawling along the side of the square from point A to B at 1 centimeter per second. How quickly is the distance between the ant and point C changing when the ant is halfway to point B? Okay, so what do we know here? Well, we've got a square here that's 30 centimeters on a side. Now it would probably help us to label this A, B, C, D. Okay. And we know that we've got this ant crawling from point A to point B. So here's the ant right here. It's going this distance. And so it's creating this little triangle here with B and C. So let's call this X, let's call this Y, okay, and this is going to be Z. What we're interested in here, actually let me zoom in, is how fast this distance is changing, Z, as I've labeled it, okay? Now, I know, the other thing I know here is that dx by dt, now let's think about this. The ant is crawling at 1 centimeter per second. Now that means that the distance that the ant is moving forward is increasing by 1 centimeter per second, but he's getting closer and closer to B, which means this is actually decreasing by 1 centimeter per second. Okay, I hope that makes sense here because it's X that's inside the triangle that I'm looking at. Okay, but the distance that the ant travels is outside the triangle. Okay, that's from like A to this point right here. That is increasing, and as that increases, X decreases. I'm also interested in what's going on here when X is equal to 15 centimeters. Okay, when the ant is halfway is what it says. Now, what I want is dz by dt. I want to know how quickly it's approaching C. And bear in mind that y in this case actually isn't a variable. It's a constant. It's going to be 30 centimeters the whole time. So now let's take a look over here and see what we've got here. We've got x squared plus 30 squared is equal to z squared. Okay. Now I'll take the derivative and we'll get 2x dx by dt. I have to do this implicitly. The derivative of that 30 squared is going to be 0. It's going to go away. And then 2z dz by dt. All right, I'm interested in dz by dt. Now I know what a lot of us do. We're going to want to put that dz by dt on the left-hand side, so I'm okay with that. The 2's will cancel here. I'll divide by that z, so this will become x over z dx by dt. Good. Now, we know that x is going to be 15 centimeters. We know that dx by dt is -1. What I don't know is what z is at this particular moment here. So I got to look at my triangle here. Okay, I know that this is going to be 15. I know that this is always 30. So what I need to do is find out what z is at that particular instant in time here. So this will be 15 squared plus 30 squared is equal to z squared. So 15 squared plus 30 squared, plus 30 squared. So I'm just doing this in my calculator here. And I will get 1,125 is equal to z squared. Now, I would love it if that had a perfect square root. It doesn't. So 1125, I'm going to just try simplifying as much as I can. So I can take out, let me just get back into this. Looks like I can take out a 15 out of that. Actually, I can do even better than that. I can take out, looks like I can take out a 75 out of that. I'm sorry. I'm bouncing all around here. I'm looking how to simplify this. I know that I can take out I can take out, oddly enough, I can take out a 15 and that'll leave me with a 5 there. Now I'm just going to double check that because I'm a little nervous that I screwed that up. No, that's what I want here. So I can take out a 15 out of that radical. So I'm left with plus or minus 15 root 5. And again, I'm only interested in the positive here, so 15 root 5 is equal to z. So now I can come back into here and make this 15 root 5. 15s will cancel, and this is left with negative 1 over root 5 centimeters per second. Negative, and that actually makes sense because as the ant is moving along A, B, it is getting closer to C. Okay, the distance is getting smaller here. Now, and again, because this doesn't really communicate to us exactly what's going on here, it's a little hard to see this. Think of it more like this. This is going to be negative 0. And to the nearest hundredth, that'll be negative 0.45 centimeters per second. That probably gives you a better understanding of how quickly that distance is changing.